and perhaps a few other people will join us as we continue in our discussion. I'd like to just start to see if anybody has any questions or comments related to yesterday. You can certainly put notes into the chat, or if you like, you can just, speak out and we will try to respond. Okay, so let's get started. I'm gonna just mention one thing briefly. In our folder, I also put a couple of readings related to interactions. So if you go there, you'll see yesterday's PowerPoint, you'll see today's PowerPoint, and you'll also see a folder that says readings. And so there's 3 short readings in there that would also you'd also find somewhat valuable as we move forward. So we'll sort of revisit those when we do some of our consulting days as far as planning professional development around interactions. But I just wanted to let you know that those papers are there if you'd like to take a look at them. And of course, yesterday we started our looking into the interactions curriculum. Once again, it is a fairly long curriculum, so it's not possible for me to sort of cover all the lessons and everything going on. What I'm trying to hopefully do is give you a feel for what the curriculum is actually all about. And of course, one of the major aspects related to the curriculum are kids actually experiencing phenomena and trying to make sense of those phenomena. And so yesterday, Peter did bring out a really important point. I don't know if Peter's here today, but yesterday, Peter brought out a really important point that a lot of these tasks, a lot of the phenomena might not work in a humid environment. And I had asked, to see if people would try. I was curious if anybody did try the tape the tape experiment last night at home or during the workday today. Anyways, I did a little searching on the web, and interesting enough, there is a YouTube that actually is fairly similar to what I described. This guy, on the other hand, if you remember yesterday, I said it's hard to do. I guess Peter is on. Anyway, I said it was hard to do with one person. This YouTuber, they actually found the way to do it just with one person. So rather than I do the demonstration, I can't do it right now here, but I'm going to play this YouTube for you. And you can actually use this.
Are you going to let the greedy heating companies and their crazy high prices decide if your family is allowed to stay warm this winter? Here's how a former NASA engineer...
We cannot see
Okay,
the
so I'm
video.
going to switch. I'm going to stop sharing. And I'm going to go share my YouTube channel. Skip the ad. And so here, before I go further, everybody can see that, correct? See the tape guy?
Yes.
Yep, okay, I see one thumb up. That's all I need to see is just one. So I'm going to play this now for you. It's not the one. Hold on. That's not the one I wanted. I'm gonna just go back and re-click on mine. Okay, so here's the sticky tape list.
We're going to show you how to do the sticky tape lab. It's pretty simple to do. You're going to take one piece of tape about this long, go ahead and stick it down on the surface of the table, and then you've got to fold over a little piece here in order to make sure that you can pull it up pretty easily. That's what we call the base tape, and then we're going to take another piece and we're going to stick it on top, and because it's on top, we call that the top tape. So I'm going to, now that I have it and it folded over, I'm going to mark it as a T, and that's the top, and then this is B for the base tape. So I'm going to do one more set. Now that we have our tapes down, next thing we're going to do is take the top tape and pull it off. So we'll pull it off pretty quick.
So this is what I thought was the interesting part about how he did this. Unfortunately, I moved ahead. I have to go back now. But anyways, this is the interesting part, that this person figured out how to do this as a one-person show. So it's pretty interesting. So I'm gonna play that again.
Tapes down. Next thing we're going to do is take the
Personal trainer,
Sorry.
you've been scammed. And
I'll get this right yet.
another piece, and we're going to stick it on top, and because it's on top, we call that the top tape. So I'm going to, now that I have it and it folded over, I'm going to mark it as a T, and that's the top, and then this is B for the base tape. So I'm going to do one more set. Now that we have our tapes down, next thing we're going to do is take the top tape and pull it off. So we'll pull it off pretty quick, and we'll set that top tape right here, and notice that it's already attracted to the wood. So we'll go ahead and see if we can get it to stick, and we can. We're going to take the other top tape and we're going to get it close to the first top tape. So I'm going to take this and just get it close to that first top tape, and you'll notice that they do repel each other. So they're pushing each other apart, which is what is supposed to happen. Now we'll take a bottom tape and we'll try to get it close to that top tape. Let's see what happens. So bottom tape, and the bottom tape, when I get it close to the top tape, you'll notice that they do attract each other. We'll put this bottom tape over here, and then we'll take the other bottom tape, and let's see how the two bottom tapes interact. So this bottom tape, when I get it close to the other bottom tape, you'll see that they, again, do repel a little bit. And that's what we want to see with the top and the bottom tapes. I now have a piece of aluminum foil and a piece of paper.
Okay, I'm gonna stop sharing. And then I'm gonna drop back into my PowerPoint. And so I hope you saw that. And what I want you to do right now is I want you to go up into breakout rooms. So Buren, if we could assign breakout rooms, we have 15, so probably 3 or 4 people, maybe 3 breakout rooms. And I want you to just spend 10 minutes trying to explain why the top tapes repel each other and the top and the bottom tapes attract each other. That's the point of that lesson. Now, you have a lot of background knowledge, so you're going to have a little bit more sophistication than the kids. But one of the things we know going in, there's 2 things we know that going in. One, we saw that a movement started. And whenever you see a movement, we know there's a force. So the question becomes, what's causing that force to cause that movement to start? And we saw this movement actually in both ways, both when the top tape was brought towards the top tape, they repelled each other. But when the bottom tape was brought towards the top tape, they attracted each other. So the question is, what causes that? What causes that movement? The other thing that's really important to consider when you're in there for 10 minutes and looking at this, what's the energy? We also know there's energy involved. Not only was there some force, because we saw that in order to get anything to start or change direction or to stop, you always have to apply a force. So that started moving, so we saw a force. But every time we see something moving, we also know there's energy, because movement shows that there's kinetic energy involved. So I want you to go and look at the tape again, or you don't have to, but I want to make sure you can play it, because if you can't use it in your school, if you can't do it real in your school, it's much better to have the kids do it hands-on. It's at least okay to do it through a video. So if you go in, watch the video, and then try to come up with an explanation, and come back and let's hear why you think those tapes are either repelling or they're attracting each other. So if we can go in the breakout rooms. Okay, so we're moving in the breakout rooms. So I'll give us about 10 minutes to get started.
And then
Okay.
yeah, and then when you pull it off, and then you just stick it on the wall, and then you do it again like the first time. And then if you bring the tape from the top to the top, if you make it closer, if the tape come from the top, it will repel each other. And then Professor Jones break the room for us to
To
discuss
discuss
about,
why it happens,
yes,
is it?
yes,
Mm, mm, mm.
the cause of the movement. Yes. Okay, how do you guys think is Pandu?
That was
Pandu,
a good,
right?
that was a good that was a good summary. You might want to consider replaying the video. So if you have the PowerPoint, you can just click on the video and you can watch it again.
Okay,
And
sure.
you'll see that how that was explained was pretty accurate, right? So the big question is, why did one repel, why did the top one, why did the bottom repel the top? But why when you put two tops or two bottoms, they attract, right? So if you put two different ones, bottom, top, they repel. On the other hand, if you bring these, if you take if you take a top and a bottom, they attract. So why is that? And you should just play the video over to watch it again, because it's pretty interesting to try to figure out what's going on. But it's probably good to watch the video if you can get it started.
Yep. Okay.
And if one of you could share your video, then everybody else could see exactly what was going on. So I'm gonna drop off and go to the next breakout room, see if they have any questions.
So we don't have the question, so we will see the video again and then discuss. So thanks a lot.
They just repel each other. And when the base tab and the top tab, which is the positive and negative, they come together, then they get close together. So yeah, that's what
So
my
become stick
opinion.
with each other. Okay.
Yeah. So
Alright.
yeah, that is what my opinion is. But
Mm.
we are basically, yeah, we can always come in and discuss on this matter.
Mm. Are there any different type of metal of B and T?
No, they are not metals. They are currently is
Not
only tape.
metals.
They're just
Okay,
tape.
okay.
Just tape.
Okay. Yep.
Nice. Well, I might ask you guys, I think I'm gonna go in and play the video really quickly again, because some
Yeah.
people weren't able to start it. And then if you could, if your
Stop
group
share.
could just share their screen, that would be great with the rest of the group and try to explain it, because we're gonna compare this to another phenomena a little bit. So this is one way of explaining this, right? We have two different objects that totally have the same type of, to have different
Charges.
charges,
Yeah.
and then they repel or attract. So I'm going to leave the breakout room. You guys can keep discussing. I'm back.
Okay, let me try to draw with the same charge. So if this is the top, and the top, so the
Hi, any comments or questions? Okay, then, well, I'm gonna leave and I'll see you in the main room in a little bit. I think we're all back. So what I'm gonna do is I'm gonna just replay that video. So I'm gonna go to my, I'm gonna replay that video. I just want to have us watch what's going on again. And then I'm gonna ask group 3, room 3, to show us the diagram that they came up with. And if they could explain what's going on in that particular situation, and then we can see if the rest of us have some questions. So the first thing I'm gonna do is just replay that video because I think it's important for us to actually see it. This is actually a really interesting video that happens in the real world, as long as you don't have humidity, but we'll see
This is what your dishwasher looks like after 1 year. It's a colony of billions of mold and bacteria
We
living
haven't
deep in
seen the,
not
we
only
have not seen the video actually.
I know, I'm putting
Hey,
it on
this
right
is
now.
Warner, and I'm gonna go through and show you how to do the sticky tape lab. It's pretty simple to do. You're gonna take one piece of tape about this long. Go ahead and stick it down on the surface of the table, and then you've got. This is Horner, and I'm gonna go through and show you how to do the sticky tape lab. It's pretty simple to do. You're gonna take one piece of tape about this long. Go ahead and stick it down on the surface of the table, and then you've got to fold over a little piece here in order to make sure that you can pull it up pretty easily. That's what we call the base tape, and then we're gonna take another piece and we're going to stick it on top, and because it's on top, we call that the top tape. So I'm going to, now that I have it and it folded over, I'm gonna mark it as a T, and that's the top, and then this is B for the base tape. So I'm gonna do one more set. Now that we have our tapes down, next thing we're gonna do is take the top tape.
So one of the things you want to consider is when he does this, try to make a prediction of what's going to happen.
And pull it off. So we'll pull it off pretty quick, and we'll set that top tape right here. And notice that it's already attracted to the wood. So we'll go ahead and see if we can get it to stick, and we can. We're gonna take the other top tape and we're going to get it close.
Now, if he takes 2 tops and he brings the 2 tops together, what do you think is going to happen? Make a prediction if he brings 2 tops together. You saw how that was attracted to the wood. What happens if he brings 2 tops together? What will you see?
Get it close to the first top tape. So I'm gonna take this and just get it close to that first top tape, and you'll notice that they do repel each other. So they're pushing each other apart, which is what is supposed to happen.
So it's a really cool phenomena to actually see it. So you should try it to see if you can't get it to work yourself.
Now we'll take a bottom tape and we'll try to get it close to that top tape. Let's see what happens. So bottom tape. And the bottom tape, when I get it close to the top tape, you'll notice that they do attract.
Again, I was trying to get you to make another prediction, but I think you can see now, instead of repelling, they
That they do
attract.
attract each other. We'll put this bottom tape over here, and then we'll take the other bottom tape, and let's see how the two bottom tapes interact. So this bottom tape, when I get it close to the other bottom tape, you'll see that they, again, do repel a little bit. And that's what we want to see with the top and the bottom tapes. I now have a piece of aluminum foil and a piece of paper.
Now, you could go on and you could watch the rest of it, but that's not the point we're trying to make. We're trying to just look at that one tape experiment. So I'm going to stop sharing there. And then I'm going to ask group room 3 if they can't share their model. I was really pleased to see that they actually drew a model to try to explain why that phenomena was occurring. So could group 3 share and talk about what happened?
Sure. Currently I'm trying to share it first. Yeah. Okay. I am not sure whether it still exists. No, the previous video is gone. The things that we have done is gone.
Sometimes it might be in your notes.
Because I didn't have the opportunity to save it. Let me try a different one. I did do a different one. Because I would predict that this one would happen. Okay, so yeah. Is this okay?
Sure. That's similar to what you had, I thought.
It's a different one. This one I draw using paint.
Can you explain what happened?
Okay, so basically, during the tape, when they were stuck together, the bottom and the top tape, they were equally, in the first place, they were equally having the electrons as well, the electrons to one another. But when we pull the top tape, so basically when we pull the top tape directly or very quickly, this top tape will literally drag all the electrons towards them. So what happened? This make the top tape is slightly negatively charged, while the bottom tape is slightly positively charged. So because of that, so when the top tape and the top tape comes to one another, they repel one another because they are having the same charges. Same with the bottom and the bottom tape. However, with the base tape, the base tape, when they are get close to the top tape, they attract one another because they have different charges. So yeah, that is our model and explanation.
Thank you. So I wonder if anybody has any comments or questions before I continue? Okay, well, thank you, group 3. So, typically in the world, objects are neutral. The interesting thing about the tape experiment is when you put those two, that piece of tape, of course, was one long stretch of tape. It's neutral. But when you put that bottom piece down and you put another top piece on top of it and you quickly rip it off, you're actually causing something to happen. You're causing them to be charged or different in some ways, right? Similar to like what a magnet is. Magnets, different poles of the magnets will repel each other. So something happened here when we rip these things off to get them to repel each other. So we know they have to be different. Right now, kids aren't going to know about electrons unless they had it previous to this. But literally what's happening is when you rip that tape off, you're moving electrons from the bottom tape to the top tape. So you get an unequal distribution of charge. You're not ripping all of them off. You're just ripping some of them off. But nevertheless, you're ripping enough off so that when you bring the two pieces of tape together, they will basically attract each other. Or if you take another top that you rip from the bottom and you put it close to each other, they will repel because of the same charge. So that's a really important aspect in this particular case. Because of the ripping, you're actually moving electrons from the bottom tape to the top tape so that they have different charges. One being, we say one's negative and we say one's positive. And so by convention, and it's only by convention, we say that the electrons are negative and what's left over is positive because one's negative and one's positive. And so we saw that the positive, the two bottoms will repel each other, the two tops will repel each other, but the bottom and a top will attract each other because one's one charge and another's another charge. That's the whole focus of that lesson. In fact, the whole, almost the whole focus of that whole unit or that whole lesson that for several days that goes on there, but it's a very important lesson. I was curious if there's any comments or questions. Okay, I'm going to share my screen again. If you do have a comment or a question, please put it in the chat. There's a more expansive sticky tape lab that's down here. I'm not going to play it, but I did find it and I thought I would just put it there for you if you want to watch it. It actually is quite interesting to watch and deal with. Okay, then I found a variety of different electric static demonstrations that I thought were really interesting. And again, these are very similar to some of the ones that are in the interactions curriculum. If you are in a very humid environment and you can't do these, then I would say use this YouTube because it really has some interesting videos associated. So I'm going to play it for a little bit because I want to show you, I want you to watch a variety of electric static interactions so that you can see what's going on. I have to stop and then reshare. You know, you'll notice in this case, the person rubbed the rod, the plastic PCV pipe with some wool, but they did not touch the can. So it's so we're going to come back and we're going to talk. So that's a slightly different phenomena than what was happening before. So it's important to understand what's going on at each step. Okay, maybe it's because I'm a chemist, or it's my background, maybe it reminds me of my childhood, I have no idea. But I can watch these kind of demonstrations all the day. I think they're just fascinating to say, why is that? Why is it that you can rub a PCV pipe with a piece of wool and then bring it towards a stream of water, and the stream of water is attracted to it? This is quite a fascinating phenomena. And if you've never seen it in real life, I would really encourage you to try it. It's just wonderful. But I'm going to back us up. I'm going to take us back to where we saw the can moving. And I'm going to replay it again. I just want you to watch it very carefully, what's going on, because then I'm going to ask you to go back into your breakout rooms and explain why the can roll, why the rod can actually control the movement of the can. What is going on? Right? So, and if you could just draw some pictures, draw a little model of trying to explain why that rod can actually attract that can. What's going on? So let's watch it again. Okay, so I'm gonna stop us there. And I'm gonna stop sharing. And then our goal, and again, you can watch that little part over in your video if you like. I would encourage you, if you don't understand the sequence, to go and look at the sequence again. What I'd like you to do is go into your breakout rooms. And once you go into your breakout rooms, what I really would like you to do is draw a model of what could possibly explain, what explanation, what model can actually explain that phenomena, right? Phenomenon. So what's going on in that particular video? So I'm going to ask and we'll do about 10 minutes to get this one started, and then we'll come back and we'll discuss what's going on in this particular video. So Bjorn, if you could put us into breakout rooms, please. I'll give you about 10 minutes.
Okay.
I'll jump into a couple of, I'll give you a minute to get started, and then I'll jump into some breakout rooms and see how you're doing.
positive charge, right? Yeah. And then how about the can? The can, because of the can is made of metal, right? So around the can should be negative, right? Should be negative.
Yeah, so when you put it nearer, that's why it looks like it's attracting it because of the different charges.
Yes.
I have a question. Is
Yeah.
what made the can, so if I would touch the can,
Okay.
Yeah.
would I get a shock? Is the can, is the can neutral? Or is the can actually charged negatively?
We think that the can is negative charge because it's made of the metal, right?
It is
And
made of metal. But what
yes.
made it, but in the real world,
Mhm,
are things charged or are they neutral?
It
mhm.
is actually neutral.
It's
Yep.
neutral.
Everything is neutral, right?
Everything in the world's neutral, right? So
Okay.
if
Yes.
the can is neutral, how does it get to move towards the positive?
Mm.
Would you please say it again, Joe?
Sure. Yeah, so
Yeah.
everything in the world is neutral, right? Here's a metal,
Yes.
this
Mhm,
is neutral. But
Yep.
when I brought the rod into that
Mhm,
Coke can is
mhm,
also neutral.
mhm.
So when I bring the positive rod towards something that's neutral,
Mhm.
why would it cause it to move? The can is neutral.
Yeah, the can is neutral.
So I think because the rod is the positive charge, and at the first time the can is neutral, so electron are easily to move when comparing to the positive charge in the can. So when we press the rod closer the can, it will like attract the electron around here, so move to, move close
Towards.
to the rod. Yeah.
Right. That's a very different explanation than you first said, right? So,
Yes. Yes.
Uh-huh.
right, it's a really hard one. The
Yeah.
that there are some kind of charges that can actually move. And so
Mhm.
there's, even though the world is made up of things that are neutral,
Mhm.
we now have some evidence that we can get, there's some different charges to them.
Mhm.
But, and so what happens in the can of the case of the can is that the things that can move, which and are opposite than the other guy, they move towards it, causing the can to move. So, and we call those electrons, right? So we know that the electrons can easily move. So that was a good explanation.
Okay. Thank you. So we have to revise our model.
Yeah, so it's not that it's all negative, right? It's just that there's
Yeah.
negative and positive. It's just that the negatives are close to how it's moving.
Yeah.
Okay, I'm gonna pop into another breakout room.
Okay. Thank you.
What was his last sentence just now? The electrons are close to. I didn't get his last sentence just now.
I
He
didn't
said
hear you
that
clearly. What? So,
he said
would you please say it again?
he
Yeah.
said that
Sorry.
the can is neutral, but
Yes.
Yeah, this is a much harder case.
Yeah.
This is a this is a much harder case than what we had before, because in
Mhm.
fact, the Coke can is is neutral. But when
Correct?
you
Yeah.
But when you bring the positive charge towards it, what you see happening is it attracts the negative that's in the can, causing it to roll, right? It's not that it pulls it off it just attracts them. So the negatives, as you try to see in the image here, is attracted more towards one side, causing it to roll, which is actually quite a fascinating phenomena to be able to explain.
Yep.
Okay, I'm gonna pop out and I'll call us all back together in a minute or two.
Peter, are you from Malaysia?
Yes, I'm from Malaysia. Murni, you're
Oh,
from Indonesia, is it?
yeah. Yes.
Pejiran kita.
Ya, tetangga, jiran. Oh, hello, Kin. Kin is from Myanmar.
Oh, Ken is from Myanmar.
No,
Kin
I'm from
from Myanmar
Cambodia.
and Kim
Oh,
from
Cambodia.
Cambodia. From
Cambodia.
Cambodia.
I am teaching a science subject.
You're teaching science
Oh,
subject?
yeah.
Yeah, earth science.
Oh, earth
Science.
science. Ah.
Yeah.
Welcome back, everybody. So we know we saw more complex phenomena. In the first example, we saw a case with the two pieces of tape. We actually saw complete, one side being more positive and the other side being negative, because actually we took some of those particles that can move, that we call electrons, off one piece of tape, causing the two pieces of tape to have opposite charges. So that's why we could see movement in those first two examples. On the other hand, and I saw some really nice, I'm going to try to share my whiteboard. And hopefully I'm going to be able to draw today. If not, I'm not going to share my whiteboard. And can everybody see my whiteboard? But once again, I cannot see my tools.
Yes.
Yes, I see everybody on my whiteboard, but my tools are not showing up again. I don't know, this is so funny. Okay, well, I can't share my whiteboard, unfortunately. Darn it all. Where are my tools?
Joe, basically, can you just press share screen, and then after that, from there onward, it should actually ask you to share the whiteboard, and you'll be able to find it, and you'll be able to edit from there.
Okay, so sharing your screen will close the whiteboard for everybody. Yeah, it doesn't say that to me, Peter.
Well,
Okay.
it is better for you to close it for everybody so that you can actually focus on it.
Yeah. I'm gonna close it. Okay, well, I'm just gonna explain what's going on. And then maybe if one of the groups want to bring up their picture, that would be great. But in this particular case, there was a real critical aspect. The critical aspect was you took the PCV pipe and you rubbed it with a piece of cloth. That actually caused the pipe to get charged. That is really important. Rubbing the PCV pipe caused something to leave that pipe, something that was movable, and causing the charge to have one type of charge, we'll say positive. Now, the can in the world, all objects are neutral. That Coke can was new, or that aluminum can, well, I think it was a Coke can, that aluminum can was neutral. How then could it possibly cause the can to move? And that's because when they bring the positive charged rod close to the can, those moving objects, which are negative, are attracted towards the positive. That's a force, right? So the PCV pipe causes those electrons to shift. There's a force causing a movement forward. And so it's not that charge leaves the can. The can is still neutral. It's just that they get drawn to one side of the can, causing it to continue to move forward. So that's what's happening in this case. And it's pretty hard to visualize. And that's why I like this model. It's actually a nice model. Both groups had some pretty interesting diagrams to show this. So you bring the positive charged rod as a result of rubbing it with the wool, what the wool then became negative. You bring it close to the can. Those moving parts that are in that neutral can are attracted, causing it to move forward. And that's a perfectly reasonable explanation of what's going on in that particular situation. So I'm gonna thank you. I think this was Peter sharing. Thank you. I don't know if anybody has any questions related to that. It's actually a very interesting phenomena. So I'm not gonna ask us to explain this, but I am gonna just show you one other video. It's right after that Coke can. So I'm gonna share my screen. Think everybody can see that. Now this happens, it's in that same video, but it's right after the Coke can. And everything we just got done saying, right, about when you take the cloth and wipe the PVC pipe, that causes a chain, that causes the pipe to become negative, right? I want you to keep all those ideas in your head, and then I want to see if you can explain what's going on in this phenomena. I'm not going to ask you, I just want you to sort of think and apply it on your own, what's going on. So I'm just going to play this. Okay, so there, just to point a couple of things out, the hanging little piece of wood, is it neutral or is it charged? It's neutral, right? So
Neutral.
all objects in the world are neutral. So it's neutral. The woman was rubbing the rod with the piece of wool. The rod is what's gonna happen to the rod?
Become positive.
It's gonna become positive. So when it brings it towards this jar, what do you think is gonna happen to that suspending object? So that's make that prediction. and let's play it. This is also another interesting one. You can ask yourself, why did the piece of wood stay attracted to the glass? And that's because it basically caused the electrons to leave where the glass was, or it became positive, and the wood piece was negative. So it was able to stick there for a little bit, even though the rod was removed. Okay, just curious if anybody has any questions. Hopefully those ideas are starting to gel in your head a little bit. They're really so critical to understand how things function in our world. To understand that the world is actually, it's neutral, but it actually is made up of charged particles that can actually be transferred from here to there and cause things to move in various ways. So I'm going to share my screen. There. Okay, so we just sort of finished investigation 1. As a result of this, we should all know that all materials are initially neutral, and so they don't attract each other. Things in the world don't attract each other. But objects can become charged through contacts with other objects or by rubbing neutral objects with friction and knocking the movable objects off. Charged objects are either positive or negative. That's by convention, right? We can do some experiments, and as you do more in the unit 1, you actually build that up yourselves. The kids actually figure that out by themselves when they go slowly through the unit. And the other thing we figured out is that similar charges repel and opposite charges attract. And charged objects, that they're either too positive or too negative, brought towards something else will actually interact with it, and we can cause things to move. And that we also know that charged objects will also attract neutral objects. Now we move on into investigation 2. In investigation 2, we begin to realize what's going on, and we start talking about there's an electric field. So I'm going to just pop out of this just for a second. And then I'm going to go and share my screen with you. Let me share my screen. Oh, I got to stop sharing. And then I got to share again. Yeah, so this brings us to one of the student activities. This is investigation 2, and in the second part there, and you can begin to kids are going to begin to build a notion of electric field. This, which basically surrounds the entire object. Now, the notion of electric field is really challenging, but it builds throughout this entire unit. So don't expect your kids to understand what an electric field is at this point. Right now, what they should understand is that it can actually impart a force, cause something else to move or repel when it's brought close to it. So fields actually permeate from some point and can cause these interactions. And so this is just a simulation that we have to try to have kids get a better sense of what's going on. And so, for instance, I can move this slider closer to 3, and you'll notice how the field actually becomes stronger. If I move it to 0, you'll notice that around particle A, it's neutral, so there's no field around it. On the other hand, if I make it negative, it once again gets a field, but that field is in opposition to the one in particle B. And so the force arrow that you see indicates that they would repel each other. So the world is typically made up of neutral objects, but if we rub them, we can actually cause something to become negative. And if we bring it towards, in this case, it should be, in some respects, attracting this particular object as well, but we can't show that. But if we make something positive, then you're going to see that the field around both of them are attractive. If we make the other object negative, then they're going to repel each other, and you can see what happens to the field. So we're beginning to help kids develop an understanding of what a field means, which is a really important concept in understanding why we can see some of the phenomena that happens at the macroscopic world, as well as explains what's happening at the microscopic world. So I'm going to stop sharing again, and then I'm going to share my screen. And that takes us through basically Unit 1. And then we're going to go on to Unit 2. So what or Unit 1, Part 2. So what I'd like you to do in this particular case, we're not going to have a whole lot of time. I'm just going to give you around 20 minutes, maybe 25 minutes. I'd like to break us up into groups. I think we only have 2 groups today. So we'll just do Group 1 and Group 2. And Group 1 can look at Investigation 1, and Group 2 could look at Investigation 2. And I'd like you to look at both as you look at these and try to get a sense of what they're all about. I'd like you to go between both the teacher materials and the student materials, right? So you want to both look at the teacher materials and the student materials. And so I'm just going to go to the Concord.org again. You can click on this. I just want to show you how you can do it. Go to Concord.org. That takes you to this page. I'm already signed in because I was in the system already. So you're going to have to sign in. And then you're going to go down the Unit 2, Part 1. And you're going to basically investigate Unit 2, Investigation 1, or Unit 2, Investigation 2. And
Excuse me,
I'd
Joe,
like you to
you
look
have
at
to
both
show
the
your
teacher
screen.
materials.
You haven't shared your screen.
I'm sorry, say again?
You haven't
Oh, I'm not
shared
sharing my, I'm
the
so
screen.
sorry. Yeah, I'm going to share it right now. I apologize. Okay, I'm just gonna, so you're gonna log into, I think everybody can see my screen now. You're gonna log in,
Yeah.
you have to log in. I'm already logged in, so I don't have to log in, but you'll need to log in. And then you're gonna come down here and you're gonna select Unit 2, Part 1. Your Unit 2, Part 1, and then you're gonna either go into Unit 1, Investigation 1, or Unit 2, Investigation 2. And again, you can look at the student materials. I'll just click on this preview. This will take you to the student materials in which you can explore, you're probably going to have time, the whole module for the students takes 315 minutes. So that's a long time. So, you're going to start just looking at, the first one here. But at the same time, if you just look at this, it's a little bit, from a teacher's perspective, you don't get the whole sense. So what I really like you to do is also, at the same time, open up the teacher guide. So you're going to click on the teacher guide. And the teacher guide will download. And then you just have to scroll through. You can see this, right? you're gonna scroll through until you can find unit 2. So we're still on activity 1. So we have to keep scrolling. Sorry, I should have looked up the page number for you and I didn't. Oh, I went too far. Anyways, I think I'll come into the breakout rooms and show you how to give you the page number. Right, well, this is where it begins. So if you, you need to scroll down to page. Oh, it says page 1, that doesn't help. Oh, that's because it's, sorry, my fault. That gives you just the introduction, to that particular one. I got mixed up with the original download. So it'll just take you right there. My apologies. Okay, I'm gonna stop sharing and ask Buren to put you all into the breakout rooms.
So I, yeah,
Oh,
so I
yes.
put in a chat box.
Okay. Physics?
I'm not sure where you're at. Interactive, no, you don't want to be, you're at the wrong spot. So I think if you go into the chat, I'll put the, I think there's
I,
a.
I remember open 3 t dot
Yeah, I think you, hold on, let me,
com or org. I don't remember.
So how about if you just click on the chat? I just put.
Oh.
well, that's the wrong, that's not the right, that takes you to Concord.
Ah, dot
It's not the
science,
right
I
link.
think.
The right link is actually on the PowerPoint. I'll
Open
go get it and give
dot
it.
science. Yeah, I remember.
I'll be right back.
Dot science. I remember. This is Michigan State, and here interaction, right? Yeah, and then
Yeah. And then unit 2, part 1. Yes.
okay.
Yes,
And
this is
which
it.
one? First one? Our
Yes.
team is the first team, or
Yes, but you have to register first.
You
Yeah.
can look at part 1, that's fine. That's good.
okay. So do I need to register?
So
Well, if you don't register, if you don't log in, then you can't look at the teacher materials unless you downloaded the book.
mhm.
Or you can register. I don't know how long it takes to register. I'm gonna pop into the other breakout room and I'll come back to see how you're doing.
Okay.
So interaction part unit 2 part 1, no, part 2, no, unit 1 part, how?
Unit 2
Part
part
1.
1. Yes.
Okay. It's a
And
little bit
then yeah,
more.
you will download the teacher guide, unit 2 part 1. Below, yes.
Investigation
Yes.
1.
Yes.
Okay. So what's the task for us?
The task is just let the group look through.
You can get in. I can show you how to. I can show you how to get in again if you'd like me to show you how to get in.
Yes, please.
Show you how to get in. Okay. So I'm gonna put in the chat a link. Can everybody see that link? That's the same link that's on the PowerPoint. So you can click on it, and I'm gonna
Yep.
share my screen. I think this, okay. So what, so I think you can see this, right?
Yep.
Oops, sorry
You
about
go
that.
to unit 1, part 2.
Yeah, sorry, I just, there you go. So then you want to scroll down
Yep.
and you want to go to unit 2, part 1,
Okay.
click on it.
Unit
And
2.
then you want to look at unit 1,
Yep.
investigation 1, or you can look at investigation 2 if you, either one or 2. The other group
Oh,
is looking at unit 1, so let's us look at investigation 2.
okay.
Again, you can open up the teacher's guide. And I think you can see this, correct?
Teacher guide.
And so this is activity 2.1. Where does an energy of a spark come from? And I'd just like you to look through it to see what's going on. At the same time, once you read this a little bit, then I'm gonna if you go back, we're in unit 2, you can preview the materials for the students. This then takes you to the student materials, and you can sort of look at what's going on in the student materials. So I'd just like you to look both at the teacher materials and the student materials for a few minutes. And I'll let you guys do, can one of you, share your screen, or do you guys want to work independently on your own machine? I'll let you guys decide that. I'm gonna actually stop sharing, and I'm gonna leave, and I'll let you guys get settled. And I'll pop back in to see how you're doing.
Yep, okay. So
So
Peter,
Murni,
can
okay, I'll share my screen.
let's
This is the
do
one, right?
the experiment together. Yeah.
So this is the student's material. We are looking at the student's material first.
Yes.
It does give a time frame, which is around 340 minutes. Let's click at the first one.
340 minutes. So, oh, 175. In Indonesia, we have 1 hour class is about 45 minutes.
Okay,
So it means that we need
around two
around
periods.
two periods to do one experiment.
I think we can actually incorporate after this, but maybe it's like we summarize it out, or maybe we exclude some of the activities so that it could actually
Yeah.
fit our students better. Some more, there is also the problems with the language, of course. My students have very weak command on English. They are quite good, but there are some of them have weak command in English, so there are problems with doing the activities unguided. Yeah.
Okay, okay. Let's try the first activity.
Okay. Estimated time 75 minutes. Let's go to introduction.
Yep.
Characterize the energy. What causes potential energy to change?
Energy
Spring.
is such an abstract thing. It's very difficult to teach. I mean, to understand. How,
Yeah, since Murni is teaching biology, it's
Yeah.
like one of a problem.
even if we want to explain about the photosynthesis and the energy change there, wow, it's very difficult for students.
Okay.
Mm-mm.
What when you feel when you're stretching and compressing? So basically, let's type in some answer. What do you feel when you stretch or compress the spring? Stretch.
Feel hard with that.
It feels hard to stretch.
Yeah.
Yes, I do agree with that. This one is for 9th and 10th grade students, right? According to Prof. Joe yesterday.
Yeah, this is why
Yeah.
I opened our book. I wanted to show you. We have for 8th grade, we have let's say chapter electrostatic.
Yeah.
It starts in 8th grade, but we don't have science. We have physics and chemistry separately. So when is,
In Thailand, in the 8th grade, we also have science. We also have the topic about electrostatics, but the question it is not too difficult like this. It's just tell the
General.
student,
Yes.
yes, in general.
General. Mm.
what questions do you have about energy?
What a question you have about the energy? What is energy? Do they?
Energy.
So just next to the next week. Yeah, next to the 3rd page.
Type of energy do you think may have been involved when the
When Bunsen
Bunsen.
burner was let whisper from the Van de Graaff generator. So I just would like to ask you guys, what is the Van de
It's
Graaff?
this one where it was. No.
This one is Bunsen burner that I know, but Van de Graaff. So
Van de Graaff was that machine that caused the pie plants to fly off. So what it does is it can actually produce an electric current or a charge, right?
oh,
It produces,
oh,
and then it has all these kind of effects. And so
Okay.
kids can explore with. You have to be a little careful. You know, here's this image of a kid putting their hands on it and his
Mhm.
hair going up. In fact, you can do that if the Van de Graaff isn't charged too much. If the Van de Graaff is charged really a lot, you can really get a bad shock. So
Mm,
it's really fun to do this. You gotta be a little careful. I mean, if you do need to be a little careful.
okay.
That's all.
Yeah. Energy and Van de Graaff generators have been involved in spark generators.
Okay, I'm gonna pop into the other breakout room.
Yep. Okay,
Now,
sure.
Any
Yeah.
comments or questions for me?
No.
No,
Okay,
no.
let's
So
keep working.
So and
I
in
ask something? I
the
was
model,
wondering.
So it should go. For the car energy, it will go up, right?
Yep.
Because it moves. And
Yeah.
for the spring, it should go down.
Down.
Okay, I think.
Is it correct like that?
Well, we'll just do this activity first.
Yeah,
Because,
yeah.
because we are supposed to do this, okay? What
Yeah,
evidence
okay.
there is, there's a potential energy in the system before the car move. The car does not move without the spring.
Mm.
Which part of the system has potential energy before the car move? Spring.
Yeah.
Question 6. Okay, so basically, yeah.
So,
Let us see if
in this activity, the student only write down the answer or doing the answering the question, but there are no feedback from the teacher, or how should
yeah.
they get the feedback?
Yes, yeah, this is another question that I actually did ask. I do feel that we need a feedback from the teachers to ensure that the students so I think this is more like a self-learning modules whereby the students actually after exploring it, they'll be able to see potential energy when they pull or stretch
Yeah.
it.
Oh, okay.
Something of such. But yeah, I think teachers need to also need to study and basically so that they will be able to guide the students when they're doing the activities.
Activity,
Yeah,
yeah.
sorry, I didn't realize my sound was off. So the teacher should be,
Sorry.
well, you know, sometimes I like to come in and just listen for a little bit, then I forget that I have my button off. Anyways, the teacher should be part of the class activities, right? So you should be walking around,
Oh, okay.
interacting with the student. But the other thing that the teacher gets, and this is very important, they can actually get a summary, and I'm going to show you this, how to do that when we do the consultations, because the consultation is all about the PD and how you would go about teaching with this to your own teachers. There is a feature in this curriculum, and this is why I want you to use the online version, that I can actually go and see, did my students complete activity? Did they complete number 4 here? Did they complete activity 4? And I can actually see their response. I have to set up my class. I have to put everybody's name in there. But once I do that and I assign them to a group, then I can actually go in and I can actually see the work they've accomplished. So I would answer your question in 2 ways. One way is this idea that the teacher should still be an active part of the class by going around and talking. But 2, the teacher can see very clearly what the kids are doing by looking at her computer screen and seeing who's completed what and they can actually even look at their responses to see if those responses are appropriate.
That is great because that was the questions I do have yesterday. It was not answered.
Yeah, I don't want to keep going. I don't want to, you guys were having a nice conversation. I don't necessarily want to interrupt it.
Yeah.
So yeah, we did see the module is actually we are having fun with the modules. Yeah, we need to see the teacher's guide also.
So Joe, I still have a question. Hello, Joe.
Yeah, I'm here.
Yeah. So, for example, the student cannot attend, or he or she absent in the class in the activity. So, does that student can do this activity at home, and then teacher will check it online, or what should the teacher do, and also the students?
You know, if the student isn't in class, they can certainly, as long as the teacher, and again, I'll show you how to do this. The teacher can assign the student this assignment, and he can go and he can do it at home, and it'll still be recorded, because remember, everything's on the internet. You know, you're
Okay.
thousands of miles away from me, and at
Okay.
least it's when you're doing the thing, the activities at school, you'll only be, you know, just a little bit away from each other. So it's all stored in the cloud, and so it's still basically, you know, the teacher can still see the material. So yes, if a student can't come to class, they can certainly continue to work with the teacher. The teacher can assign it to the kid, and the kid can actually do the work.
Okay.
I think I opened the wrong teacher's guide, is it?
No, as long as you well, go, I don't know where you were. Go back to where you were, Peter.
No, because I'm looking for the teacher's guide. Because want to see related to this.
Activity 2.
Yeah, again, if you go back to the Concorde site, I'll show you how to do this.
Okay, this one.
You were there. Just click
Unit
on the
2.
teacher guide.
Okay.
Unit 2 investigation 2.
Okay.
Okay, so you probably need to go back. That doesn't have it.
Okay.
So go back, go back, and go to your investigation 2, and click on the teacher guide. Is that where you were at? No, which one are you? Are you investigation 2, right?
Yeah.
Investigation 2 means
Okay, so go to unit 2
where
investigation.
does the energy of a spark?
Yeah, so click,
No
so
problem.
Peter, go there, and it's below it. Below it, not on top of it,
Below.
below it. Yeah.
Yep.
Okay. Okay. This one, yeah.
Yes.
Okay. Thank you so much.
Well, I want you to feel, if you don't feel comfortable with the materials, you're not going to be able to look at them, right? So you gotta sort of just play around with them for a little bit.
Okay.
Okay, I'll let you guys work for another minute or two. I'm gonna pop out. I'll give you, you know, one more minute, and then I'm gonna call you back.
So we need the source of electricity. How do we call anode, cathode? Is it correct?
Yes, anode is positive, the positive terminal. Cathode is the negative one.
Cathode, yeah, okay. So we need anode, cathode, and a very close distance between them. So the spark goes to be continuous.
I think that spark can be accumulate heat when they have heat, so they can lit the bunsen.
So it accumulates heat, right?
Yes. Because
The spark
yeah,
accumulate heat. So
Mm.
yeah, so when enough heat, it can cause its burn.
Bunsen burner to light up.
So what's
Yes.
what's the heat? We call heat when molecules of substance has more energy, right? For example, cold water and hot water, a difference between them, just the motion of molecules.
Heat has no particle.
I think all the breakout rooms have closed, so I'm gonna start our general discussion. And in this large group discussion, I just would like to know what you've noticed about working in investigation 2 and what questions that you might have. So I'd like to wrap up by hearing some of your comments. I am going to take us in and I'm going to show you one point on my own, but I'd first like to hear what ideas or comments you have with regard to investigation 2. Unit 2 unit 2. Any comments or questions? Okay, well, I'm gonna, oh, go ahead.
With our team, we try to understand how spark can occur, can start a fire. So it was good, I think, brainstorming, but we didn't finish.
Yeah,
we think, yes,
I didn't
spark,
think, go ahead.
we think spark can create some heat, and but I still don't understand how it works.
That's right. It's a very so that's why it's a very interesting topic. And of course, in 20 minutes, you're not going to be able to figure that out, right? Again, the unit, if we go to the teacher materials, so I'm going to stop sharing, and I'm just going to use your example. Let me get it open. Get my teacher materials open. Here they are. Okay. So now I can share my screen. So we're in unit 2, part 1. How does a small spark trigger a huge explosion? And I'm just gonna jump down here. What is what is happening when a spark occurs. So I'm just gonna click on that one. And one of the things I'm gonna point out, because I saw a little confusion in one of the groups, the teacher guide is always below it, not above it. You'll notice the white part basically is all related to Unit 1, Investigation 1. So its teacher guide is below. The student materials are to the right. You go to preview. So I'm just gonna pop out. Is this the one that you're in, Durin? You were here, right?
Yeah.
Yeah. Okay, so I'm gonna click on that teacher guide. And again, these are all the teacher guides. It's really important to read them. This unit really starts getting into helping kids understand understanding energy. And understanding energy is a concept that can be transferred from one place to another place. And if we keep once again, it talks about the disciplinary core ideas and the cross-cutting concepts and the science and engineering practices. Here again, we're focusing on when kinetic energy of an object changes, there is inevitably some other change in energy in some other at some time. So if I see an object moving and it collides, a change is going to happen in something else. So I'm just scrolling down. I want to get to where so you'll just see, so it tells you a little bit more background information for you, the teacher. These are very challenging activities, but each one of these units, you'll notice just activity 1.1, can my finger start a fire, takes 45 minutes. So I didn't expect for you to get through it in 20 minutes. I just wanted you to get a sense of the unit. You'll also notice that activity 1.2 can last 180 minutes. So these are long involved, these are long units, but they really support kids in developing some very important understandings. And as they go through this. So teachers really have to do some preparations on their own in order to get through all these units. But, in the end, the lessons that are learned are very important. So I'm going to actually go back because I didn't expect you to get through all this, but I want to go back just for a second to here. And so right now we were just looking a little bit at Unit 1, Investigation 1, but I'm going to go into, this is true of a lot of the lessons, but I want to just show you this because I think it's really important to emphasize why these materials are so important. So I'm going to go to you'll notice in Unit 2, Investigation 2, the teacher guide is at the bottom. I actually want to go to the student material. So I'm going to click preview because I haven't assigned this to anybody. So I'm going to go to preview. And then I'm going to click on how does potential energy change when things are pushed or pulled? Now, potential energy is a really challenging concept for kids. But one of the things I like about this particular activity, it has a really nice simulation to it. So I'm going to just blow up my screen a little bit so you can see it better. So I think you can all see this. And this is actually a really important simulation because it can show kids what happens to the potential energy. So you'll notice when the spring is at its neutral position, the potential energy in the spring is very low. On the other hand, when I push the spring in, the potential energy gets really high. If I pull it out, I also get it to be the potential energy very high, which basically indicates that when I let go of that spring, right? It's gonna go back to its neutral position. And one of the things we can do is not only just look at if we start this simulation, we can not only look at its potential energy, we can see what happens to the potential energy, the kinetic energy, and the thermal energy. Because often when energy is transferred, not all of it will get transferred to useful kinetic energy. Some of it will get transferred to thermal energy to the environment. So I'm just gonna start this, and you'll notice I'm gonna stop, and I'm gonna push this in. So I'm gonna start with fairly high potential energy, and watch what, you know, as I let go of my spring, try to make a prediction in your head about what's going to happen to the potential energy of the spring, what's going to happen to the kinetic energy, and what's going to happen to the thermal energy. So now I'm going to start. And you really get a wonderful graph to show that the potential energy of the spring gets converted or gets transferred to the kinetic energy of the spring. But then the spring goes out or goes back, it goes out or comes back in, forming new potential energy, which then once again is converted to kinetic energy. But eventually we see the spring slowing down. And the question goes, where did the energy go? Remember, one of the most fundamental principles of physics, of science, is that energy is neither created or destroyed, right? That concept that it's neither created or destroyed, but then where does it go? And of course, where it goes in the thermal energy in the surroundings. So energy is never lost. It's always transferred somewhere. But often we have inefficient systems. Those inefficient systems mean that energy is being transferred to the environment. I'll just play that once again so you can watch it. I'm going to reset. I'll again start with fairly high potential energy. And then I'm going to say start. And the kids can watch and they can see how as I do that, the potential energy has changed into kinetic energy, and then back in the potential energy, but there's also energy at the same time being transferred into the system as thermal energy of the molecules in the system. So these activities and having the kids at the same time taking snapshots to answer these simulations. Snapshots are, they can take a picture of the screen. And then answering these questions is conservation of energy applied to a system shown in this simulation. Justify your answer. It really helps them build really rich understandings of potential energy, kinetic energy, thermal energy. Now, one of the most important, this lesson, why it deals with a spring, I'm going to reset it again, is so important in understanding a bond. Why does one atom attract another atom? And it certainly isn't in this position, right? If there's high potential energy, it could either be attracted or repulsed. But when you look at chemical bond energy, you'll realize when you study why things bond as you go further in, what you realize is that atoms come together because they reach that neutral point. Just like when the spring comes to a neutral point, it goes to the lowest possible potential energy, and that's where the bond occurs. And that is such an important lesson. And so it does take time to work through all these units. Once again, going back to the teacher materials. Oop, I didn't mean to stop. I think everybody can see that. Going back to the teacher materials, right? We can see then in fact, these lessons take a while. But as you work through them, it really helps kids develop important, deep understanding of really challenging concepts of forces, attraction and negative, energy, potential energy, kinetic energy, and thermal energy. And those are the only three forms of energy that we deal with. Because again, you don't want to get kids confused and thinking there are all sorts of forms of energy. No, there's not. There's potential energy, there's kinetic energy. Those are the two major forms. The other ones are just manifestations, right? So light is a manifestation of energy. It allows us energies being transferred. It itself is not a form of energy. Anyways, we've reached our 9 o'clock. I will stop and see if there's any, I'm going to stop sharing. I'll see if there's any questions.
Can we say that the temperature of spring becoming bigger after collision? Not collision, after some oscillation, right? Because potential energy transfers to thermal energy.
Darren, I didn't understand your question again. Say it again.
I mean, if potential energy transfers to thermal energy, can we say that temperature of spring increased?
That's correct. The temperature of the spring and the temperature of the surroundings would have increased, right? So you have the potential energy transferring to kinetic energy. That transferring actually also causes the movement of the spring will also heat up some of the molecules that are around it. But even if there's no molecules around it, there'll still be, as you said, Darren, there'll still be a transfer of kinetic energy to warm up the spring itself. So you'll see the spring, it'll still reach a neutral position, but the spring will get warm. That's where it all transfers to. It'll probably go longer actually, if we were at in a vacuum.
The hardest point, I think, to understand how friction can create, I mean, the temperature is a value which shows you average velocity of molecules inside.
Kinetic energy, yes.
So how friction can increase the average velocity of molecules? So this is, I think, the hardest point to understand.
Yeah, it is. Again, it has to do with collisions that are occurring, right? The collisions of the atom is what transfer, and of course, and that's what causes it to warm up. Anyways, I apologize. I do have another meeting. In a couple of weeks, we will come back and visit interactions once again. And then on Tuesday of next week, we're actually going to get together and start talking about how you will do your own professional development. And we're going to do that with relationship to water quality. Okay, well, I have to go. Everybody have a good evening, sleep well, and I'll see you on Tuesday morning. Or your Tuesday night, my Tuesday morning.
Yeah.
Bye-bye.
Thank you.
Bye.
Bye. Bye. Thank you.
Bye.